All right, let's continue with section 1.3, looking at classroom example 4. So now we want to divide fractions. Well, when you divide fractions, it's a two-step process. The first step is to replace the division with multiplication. I'm using X for multiplication. And second, you use the reciprocal. In other words, you swap numerator and denominator of the second fraction. So you change every division problem into a multiplication problem. So 2 over 9 divided by 3 over 4 is going to become, you're going to change this division to multiplication, and rather than using 3 over 4, you're going to use 4 over 3. And now it's a multiplication problem, and you multiply across. 2 times 4 is 8, and 3 times 9 is, or 9 times 3 is 27. So your answer is 8 over 27. So division problems become multiplication problems using the reciprocal of the second fraction. Why don't you go ahead and practice on practice 4. All right, so now we're going to get into adding and subtracting fractions. When you multiply and divide fractions, you do not have to have a common denominator. But when you add or subtract fractions, the fractions must have the same denominator before they can be added or subtracted. And so that's why there's often a first step before you can do your addition or subtraction. So here we have 13 over 10 minus 3 over 10. Well, we're very lucky because the first fraction has 10 as the denominator and the second fraction has 10 as the denominator. So we are going to keep the denominator, and all we do is, in this case, perform the subtraction in the numerator. 13 minus 3 is 10. So do we want to leave our answer as 10 over 10? No, we're math people. We wanted any number over itself is always 1. So we would want to simplify that answer to 1. So why don't you go ahead and try practice 5. All right, moving on to classroom example 6. Now, if you know fractions are going to have the same denominator, you're going to have to rewrite fractions with a specific denominator. We've already gone through reducing fractions, but this is, at times, you're going to take a reduced fraction and maybe put it in a non-reduced form so it has the particular denominator you're looking for. So in this question, we were asked to write 3 over 7 as an equivalent fraction that has a denominator of 42. So let's say we're using 3 over 7 in some addition or subtraction, and 42 is the denominator of the other fraction. We need to get this 3 over 7 in its equivalent form with a 42 in the denominator. All right, so what did I have to multiply 7 by to get 42? In other words, 42 divided by 7. 7 times 6 is 42. Well, you cannot just multiply a denominator by 6. Whatever you do to the denominator, you have to do to the numerator. So I'm going to multiply my fraction 3 over 7 by 6 over 6. Remember, this is just like multiplying by 1. Any number over itself is 1. So now let's multiply across. 3 times 6 is 18. And 7 times 6 is 42. An equivalent fraction. An equivalent fraction with a denominator of 42 instead of a denominator of 7 is 18 over 42.